Okay, once the interface has completed loading, we will be presented with a screen such as this, where we can see this will be the XOD workspace. Here on the left, we have a number of tabs with the components that we will be using in our projects. Here, if it's your first time or you are just starting XOD for a new session, you will be welcome with this dialog box, which actually tells you welcome back, and has this link for a tutorial for the newbie. Actually, I'm going to click on it. You'll see it by default takes you to number 1, hello. But here on the left, you'll see a number of other tiny mini projects that I strongly recommend you to complete or have a look if you are serious about XOD. If you like to speed up your learning. It has a number of components, uploading. In this tutorial, we're trying to speed up all this, so we're going to be covering very quickly a number of concepts that are vital for your learning curve to be a little bit less painful. Also, if you don't have much time, you can just watch this video and catch up a number of things. So, every single XOD program allows you to have a documentation dialog box where every time you program something, you can just type into it, and then if you develop a library or you want to distribute some of your patches, you would enter the text and the instructions there, and that would be easier for other people to understand what you try to do. Okay, so I'm going to close all these guys, and I want to start a new project. File, new project here, and here we are. This would be our buzzer project. First of all, one thing that I would like you to know is that the buzzer component was written in C++ and wrapped. So if you attended the Biomaker sessions, you probably know this, but if you have no idea of what this Biomaker is, let me just show you how to load a library online. You need to be connected to the internet for this. I'm just gonna type the name of the library, Marco Aita /MA library. It's search for it, there it is, and we import it. We're going to import it. As you see, the library appears here on your left. It's got a number of things. Now, as you remember, we only need as hardware pieces buttons, LEDs, and the buzzer. So if we go here into XOD common hardware, we'll have buttons. So I'm going to put 2 of these buttons here. I'm going to search for 2 LEDs, put them here, and then from Marco's library I'm just going to add a buzzer. Here it is. In an upcoming video we will cover how to program a component by yourself real quickly, but for now this is it. Okay, so this pretty much almost covers our little project. We only need to add components that would contain the logic of what we want the little circuit to do. However, the first thing that we need to do is to click in each one of these hardware components and be sure that they are plugged into the proper ports of the Arduino. If you look at the integrated shield, you would notice that both buttons and the LEDs would have attached to them a number, and that number actually is a number and a letter. That would be a D or an A. The A refers to analog ports and D to digital. So in the case of the buttons, you need to have ports D2 and D3. In the case of the LEDs, you need to have 13 and 12, I think. I'm just going to call this guy 13. And the other LED will go to 12. If I'm not wrong, I think I am right. And another very cool thing that you can do is, again, let's select this button and actually add some sort of description to it. Let's just add button D2. You'll see here it changes. And for this guy, let's put button D3. Same for the LEDs. We can have LED 13. For this guy, LED 12. And here we are. It's at this very stage in which XOD starts to shine, because now it's just a matter of solving the problem of what we want the buzzer to do and how do we want these components to react to certain signals. If we notice the buttons, they would have a number of options here. One of these is the action that we would like to do when the button is pressed, PRS here. So what we want them to do is to send a signal. So, but because we want these signals to be only one-offs, so you press it and press it again, you don't. You need a component that actually does that. So we want to send a pulse, and then we want to repeat the action. For instance, if we want the LEDs to turn on and off a number of times every time we press the button, we need to somehow encode those actions in this patch. The way we did this, for instance, it's by choosing in the XOD bits, I think you will have, no, not bits, sorry, it's in the core library. We have a bunch of logical operations like gates, flip-flops, etc. So in this case, we can look for the component that it's pulse on true. So every time this action takes place, the logical action is set this to true and connect this to the outcome of pressing each button. We are also going to add a delay for this to take place in times that are actually they're not too fast, so we can actually have a break in between events. In this case, let's put a delay of, let's say, 1 second. I think it's seconds, could be milliseconds, but I think it's seconds. So once this delay is activated, we will send this to another logical component, in this case an OR, which will tell the program if it's one button or the other, do something. Okay, so the activated node goes to the entries of the OR, and let's do the same for the other button. Now we also want, once this signal or this signal have been triggered, we need to send yet another pulse to a component that would iterate the on and off a number of repeated occasions. It will swap the value, the logical value, a number of times to say, okay, now you're on, you're off, you're on, you're off. So we need to do that using a flip n. It's another component that XOD provides. We need to flip n times. And again, in order to send signals, we use pulses on true. So let's find our pulse on true here. This, of course, is not the only solution. You can come up with a probably more efficient solution if you think a little bit about the logic of the problem. But, well, just to be quick, let's just do this. So we have this connection. Once this is executed like the number of times that we want, we need to specify flip n times. We need to specify the number of times we want this action to be carried out. So we want this to blink 5 times, let's say. And the times for on and off need to be also brief, so it needs to be a blink. You can see I'm gonna set this to 0.1 and 0.1, so you'll see a clearly defined blink as I showed in the video earlier. So we are set. Once this is happening, we need that every time this change in logical value takes place, we want to then change the value of the output, so the LED is then set on or off. So in order to do so, we just use a not, which just swaps the value to the negative or the negation value of the output every time. And here we are. We put a not, and then we add this to the value of the LED. So this is it. We have completed the first part of the program for the LED. Now we want also this to make a noise, so let's take the output of the OR value and put it into the entry value of the buzzer. Perfect. Okay, once the buzzer has completed its task, what we want to do is yet again to make the little LEDs to blink. So we can do something very similar to what we did with the other button action. We can look for flip n times. I'm gonna grab it, I'm gonna put it here. So once you're done, we pass this to the set value. Let's again change these values. This is the number of times the blinking will take place and the times for these values to be on and off. Here we are. This is it. Now we only need to let the LED here on the left to know that this is taking place, so it needs to be changing the previous value every time this signal is triggered. We go to not, and then we go to the luminosity, which is again a Boolean type of value. And this would be it. Once this is the full circuit, the full diagram, the full program that you need to upload to your Arduino. As you see, we are not coding a single line. All it's a graphical sort of a logic hardware set of connections, and the last thing we need to do is just to upload it to the Arduino. As we checked on the beginning, we need to check that the Arduino is connected here. We press upload. We can check the state of the uploading process here. There it is, done, and we're all set. We can test our circuit now. Okay, that's all.